Okay, so in this exercise, we are given that the A vector is pointing along the x-axis. So let's first draw the x and y coordinates. Okay, so this is my y-axis pointing upwards, and this is my x-axis pointing to the right. So the A vector is pointing in the positive x direction and has a length of 3 units. So this is my A vector. And then the B vector is pointing in the negative y-axis, in the negative y direction, and has 4 units. So 1, 2, 3, and 4. So this is my B vector. In part A, we need to find out the sum of the two vectors. Let's call it R, the resultant, which is A plus B. Now, in the lecture, we've learned that when we have two vectors adding up, we just follow the standard parallelogram rule. So in this case, our parallelogram is a rectangle, and this is the diagonal. So this is our resultant vector R. So now let's find out what is the magnitude of that R vector. Now, just by looking at this rectangle, you can see that we can use the standard Pythagorean theorem. So R squared is equal to the length of A squared plus B squared, which means that the magnitude of the resultant vector would be the square root of A squared plus B squared. So in this case, A is 3, so 3 squared, plus B is 4 squared, square root. This gives us 5. So the length of the R vector is 5 units. Now, a vector, in addition to its magnitude, is also specified by its direction. So in this case, we have to find this angle here. So let's call this angle theta. Well, just by observing this triangle, you can see that tangent of that theta is equal to the opposite over adjacent. So in this case, opposite is the length of this vector B. So B vector over the length of A vector. So angle theta is equal to tangent inverse of B over the length of A. So this becomes tangent inverse of 4 over 3. Now if you work out the mathematics, 4 over 3 gives you 53 degrees. You can use your calculator to find this. So your angle is 53 degrees. Now, note that angle theta is pointing in a clockwise direction. And usually when we count the angle, we go counterclockwise from the x-axis. So in this case, you can also say that the angle theta is minus 53 degrees, or you can say it's 53 degrees below the x-axis without using the negative sign. In part B of this exercise, we need to find A minus B. So let's do that. So part B, the resultant vector is A minus B. Now the way we can find this is, instead of writing it as a minus b, let's say that this is equal to a plus minus b. So in other words, we are adding a negative b vector to a. So again, it's an addition. So from this point of view, if you look at this picture, b is pointing in the negative y direction. So the negative of b will be pointing in the positive y direction. So it's exactly the same length. So 1, 2, 3, and 4, but it's pointing upwards. And this is your minus b vector. Now, once you have this vector and this vector, again you can follow the standard parallelogram addition. So here it is, and this is your r vector. Well, let's put a subscript here, rb, to specify that this is for part b. Well, just from the symmetry of the problem, you can see that the length of the rb vector has to be the same. So it's going to be 5 units as well. It's just a, a symmetric diagonal of this rectangle with respect to this one, with respect to the x-axis. So it has the same units, and clearly it has the same angle as well. So this angle here is also 53 degrees. So you can say that our vector is pointing 53 degrees above x-axis, or just 53 degrees. Whereas here, this r vector, which is for part A, was pointing 53 degrees below x-axis, or negative 53 degrees. Now, let's also write one more thing here. Let's use I and j notation to represent this r vector, rb vector. In an ij notation, you can say that rb vector is equal to 3i plus 4j. So whenever you state the result of the vector, the final result has to be either in an ij notation, or you should give its length and the angle with respect to one of the x's, either x or y, and show it on a diagram.